right, today we're going to do Unit 4, Lesson 15, which is on probability distributions. So what we're going to be doing here is setting up some tables so that we can figure out what the probability of getting particular things are. So the first thing that we're going to do is what's called sample space. So you need to know how many times something occurs. On your formula sheet, you've got like rolling 2 dice. There's stuff on cards on there, but for instance, let's say it's something that's either not on the formula sheet or you just don't know, such as flipping coins. So let's say you're going to flip 3 coins. I want to find the probability of getting 0 tails, 1, 2, or 3 tails. So if I'm flipping 3 coins, here is the sample space. I could get, turn this on. I could get all heads. I could get heads, heads, and tails. I could get heads, then tails, then heads. These two are different. This is getting tails on a different coin than this one. I could do heads, tails, and tails. I could do all tails. I could do tails and heads, and you get the idea here. So there's 8 different ways that you could flip 3 coins. Okay. So in a probability distribution, we're going to make a table like this here that will give you all of the possible outcomes that can happen. So to get, and I'm looking at this from the perspective of number of tails. I could do the same thing with number of heads, but this particular one asks for tails. So when you flip those 3 coins, you could get none, you could get 1, you could get 2, or you could get 3. So to get 0 tails, that would just be this one out of the 8. To get 1 tail would be this one, and this one, and this one. So 3 out of 8. To get 2 tails, this one, and this one. So there's another 3 out of 8. And then to get all tails would be that one. So 1 out of 8. And if you take, in this case, 4 fractions, doesn't have to be 4, but this particular one has 4. If you add those up, you should get a total of 100%. So in this case, 8 out of 8. All right, same idea with this one here. I want to create a probability distribution that represents the number of trips of 5 nights or more that Americans take per year. All right, so this would be trips. Oops. This would be the probability of the trips. So it's always what you're analyzing on top and its probability on bottom. Okay, take no trips. There is a 6% chance. I'm going to write these as decimals. You could write them as percentages. You could write them as fractions. You could take that and write that as 6 over 100 or reduce it to 3 over 50. If it's written in a percent, I prefer to just write it as a decimal because when we use the calculator, that's how we're going to type it in anyway. If it's a fraction like these up here, just leave them as fractions. It's easy enough to type in the fraction, especially if you get something like 1/3, which is a repeating decimal, and then what do you do with that? It's just easier to leave it as fractions if it's that, and change it to a decimal if it's given as a percent, or if it's given as a decimal, just put it as that. All right, 70% take 1, 20% take 2. You don't necessarily have to put 0.20. You can just put 0.2 if you want to. 3% take 3. That is 0.03, not 0.3. And 1% take 4. And if you would take and add these up here, that's 90, 96, 99, 100%. Okay. So what we're going to do with these is we're going to find a weighted mean and a standard deviation. Now, we did that. We did weighted mean back in Unit 2. It's significantly easier for this stuff to use the calculator as opposed to Google Sheets because it's really hard to do standard deviation for a table. It's easy to do it for a list, but for a table, it's not as easy. So I'm just going to show it here with the calculator because it's just easier. So essentially in your calculator, you go under Stat state, sorry, stat. Here, I'll pull it up here too. So go stat, edit. Then your whatever you're analyzing goes in L1, and your probability of whatever you're analyzing goes in L2. And then you do one var stats, L1 and L2. Depending on what calculator you have, it'll give you either a menu or you have to type this in. I will show you what that looks like here in a second. Okay, so if I want to find the mean and the standard deviation from that previous example over here with the number of trips. All right, clear out your lists if there's anything in there. Like I've got here, make sure it's L1 and L2. If it's not, then ask me and I will help you fix that. Type in your numbers. Make sure you don't screw up any numbers. Okay, and stat, calc, one var stats. This should say L1. This needs to say L2. So L2 is right above here on the 2. So if it doesn't already say L2, second and the number 2 puts that right there. To calculate, it'll pop that stuff up there. Your mean is 1.23, and your standard deviation is approximately 0.65. So mean 1.23, standard deviation 0.65. Okay. All right, last thing, expected value. Expected value is essentially how much you expect to win or lose. Now, this is mathematically, not I think I'm going to go to the casino and I just erased all that. Not I'm going to go to the casino and I expect to win $1 million. That's not what it means. So mathematically, based on the odds and probabilities of the game, what would you expect every time you play the game to win or lose? Now, you go to a casino, the expected value in casino games are negative. So you're going to lose money. Doesn't mean you will lose money, but it's what you expect to do. Okay? Otherwise, casinos wouldn't be in business. All right. So 1,000 tickets are sold for $1 each for a smartphone valued at $350. That's a pretty cheap smartphone. What is the expected value if a person purchases a ticket? All right. So there are two outcomes here. One outcome is you could lose. So you'd lose your $1. The other outcome is you'd win. Now, if it's valued at $350, but you paid $1 to play the game, you've actually won $349. So if there's 1,000 tickets, 1 out of the 1,000 will win. The other 999 would lose. Remember, this has to total up to 100%. So in this case, 1,000 out of 1,000. And then you go into your calculator and go back to stat and edit and type in your lists and then do, so expected value is the mean. Probably should have said that at the beginning, right? And we'll write that down in a second. So -1 and 349. Now watch when I type in the fractions on this one. I talked about that earlier. When you type in 999 divided by 1,000, it'll just convert it. It'll write it as a decimal there for you. You want to put it as the decimal, that's fine. It's just easy enough to type the fraction. That way you don't have to worry about what the decimal approximation is. Stat, calc, one of our stats. Make sure that says L1 and L2, which it should if you already did it once. And then -0.65 is the mean. So that means you would expect to lose 65 cents each time you play. Now you say, well, it's impossible to lose 65 cents if you're paying $1, but this is on average every time you play the game. So expected value works more of if you're playing it for a long time, what's going to happen. So on average, you would lose 65 cents every time you would play. Okay, let's set these up here. 175 tickets are sold at $1 for those prizes there. We're going to assume that it's one of each one of those prizes. It doesn't say that there was, 3 of these and 2 of these. That would change the problem if it did. All right, so you can lose $1. You could win 99 because remember you paid $1. You could win 49. You could win 24. You could win 9. So each of these is 1 out of 175. Now again, if it would have said that there are 2 $10 prizes, then this would have been 2 out of 175. And because that's 4, then it'd be the other 171 out of 175 for losing the $1. Okay, plug this into the calculator. I'm just going to give you the answer here. So it's 0.057. So that means you would expect to win a little less than 6 cents. So this is a good game to play because on average you're going to win. Again, doesn't mean that you will win. But theoretically, you want to play games that you have an expected positive value if possible. What if in the previous example the tickets were sold for $5 instead of $1? All right, if that's the case, still the same numbers. No, I'm sorry, it's not the same values down here. So instead you would have the -5, and now this would be 95, 45, 20, and 5. Still the same. Sorry, that says 171. Still the same probabilities. And you can do one of two things. You can plug this back into the calculator, or what would actually happen is the expected value would be $4 less than what this is. Either way, you're going to have, it'll be negative $3.94. So you'd expect to lose $3.94 per ticket on average. Okay, that is lesson 15. Let me know if you have any questions.